So today I'd like to introduce WebXR as a title with the WebXR current position and beyond to the recommendation. So in this talk, I first will give an overview of WebXR, which is a XR implementation by the web. By means you can run XR environment using your browser or browsers in HMD or some XR dedicated system. And also I will give some recent updates on WebXR ecosystem and expectation to get forward. And also at the last part I will give some updates from emerging points. I've picked 3 points for this area, so please enjoy my talk to the end. Please note that this talk will touch only for WebXR overview and its ecosystem by specification point of view, but not client libraries such as 3JS or Unity. So let me first introduce what is a WebXR. So WebXR, as I said, enables accessing XR behavior on browser using JavaScript APIs. So you can directly run XR environment using browser or usual HTML and JS environment using web browser on HMD or smartphone. You may run some AR contents on your smartphone using WebXR, like Chrome has some feature to run AR mode on smartphone. So WebXR does handle XR view, both HMD and flat screen like your smartphone. So WebXR enables you to run XR both on HMD and flat screen. Of course, for HMD, there is a 2 screen for left and right eyes. So WebXR handles this presentation like not like a usual web browser has only one window, but for HMD there will be 2 views for one scene on right and left eyes. So WebXR core system will handle that representation from usual web content. And also it is a quite important feature to connect input sources, like for games, gamepad will be used, and also Oculus headset use gamepad-like controllers to be handled by both hands, right and left hand. And also in recent HMDs, XR system can detect your hand by means of 5 fingers with joints, or you can use your measurement of distance from your HMD device to physical object. Such kind of input sources will be connected through WebXR system through JS API. Also, many additional modules handled XR features are also provided, and also in incubation. But WebXR does not render 3D content. So if you want to render some 3D object in GLTF or USDZ, you need underlying 3D rendering system like a WebGL or WebGPU. Also, WebXR is based on the web system, so cross-site handling we rely on usual web behavior, including COAS or some other limitation specified to domain. So like a Metaverse not like a Metaverse engine, WebXR will run within one website. So, as a standard, WebXR specifications are developed under the immersive web groups in the W3C, both working group and community group for making standard and for incubations. Now, WebXR ecosystem is consistent with two large parts. One is a core spec, which operates an underlying system of the WebXR called as a core, and over that there is many modules to extend WebXR core to introduce many features. So WebXR device API called as a core is placed as an extendable core functionality, which handles the basic XR device and session with simple 3D space coordinate conversions, and also providing a base interfaces to be extended by modules. Over that, many modules are built on top of the core spec. For now, there is around 20 or more modules to handle dedicated features, like AR is provided by AR modules, which enables you to use the AR session on WebXR, and also many and wide variety of XR features like game part I already said is enabled by single modules, or many other features are provided as modules. And recently there are some updates in WebXR as a standard track. So WebXR device API core feature has been mostly stable, but as some of you already know, only Chromium has a partly implemented core feature, but other web engines like Gecko or WebKit has some implementation, but behind the flag. So you need to use, if you want to use WebXR on your Firefox or Safari, you need to enable feature using a flag. So due to that, and also requirement of two implementation to become a standard, groups are considering to keep updating core modules as a living standard to have a snapshot yearly or some more longer phase. Also, some extending modules are already widely implemented, like AR modules or some input modules are widely implemented, but also some implementations like on our HMDs rely on the hardware feature of each device. So on that feature, many modules are independently implemented on Oculus or many other devices. So some of extension modules are considered to become a recommendation in near future. So let me jump into a recent update in more modules under incubation. So as you can see in many presentations around the XR area, there is a bunch of new features or new target introduced to XR ecosystem itself. So like a metaverse or physical AI newly brought into the XR ecosystem, but which has not been implemented yet widely on the ecosystem. So these kind of new incubations are continued to be brought also into the WebXR ecosystem as a new modules, and also like update of underlying system requires a new module, like a web GPU is somehow nearer than WebXR. So to integrate a web GPU into WebXR system, there is some need to have extended modules dedicated to web GPU. Also, as you know, by physical AI or some other keywords, physical integration, including extending AR feature with physical devices or physical objects are emerging point. So this is quite similar to usual XR space. Many features from so-called metaverse is getting emerging topic, and many related features are also discussed as an incubation within WebXR. And in related to that, Metaverse Standardization Forum announced a new working group last year or 2 years ago, called as OMBI, and the OMBI announced a new Metaverse browser engine in this year. Now they released one open source implementation called as Sneeze, which runs as an application on HMDs to enable metaverse feature based on a web API and web-based data formats. So also from this kind of updates, new modules might be came into WebXR ecosystem in near future. Also, for the last point, 3D asset as a first citizen was already discussed over a long time in the web, but recently due to advancement of hardware and also system software, 3D asset as a first citizen is considered as an emerging point in the web ecosystem. Like a new model element has been proposed under incubation over 2 years to enable 3D asset to be handled on the web, similar to image or video tag, video element, and also many other features related to 3D rendering or 3D modeling, or to have a 3D or physical surface on the web, like having a physical related surfaces on HTML element has been discussed. So let me jump into this emerging point within WebXR, including its long history. After While XR, which started from WebVR around 2017, and WebXR itself started from 2018 or something. After that, many new devices and also many new headsets like Oculus, Microsoft HoloLens or Apple Vision Pro has been introduced with a new feature and new software ideas. So bunch of evolution happened both over the hardware and software, and from each point, a new emerging requirement has been introduced to the entire XR, as well as WebXR gets some new ideas from such kind of entire XR ecosystem. So let me jump in and pick 3 emerging points in details. So first is the web GPU. as web GPU started around 2019 to enable GPU usage via JS API from the web applications. So at that time, WebXR already matured using a WebGL as underlying 3D rendering system. So we watched the evolution of Web GPU, and recently, like 2-3 years ago, Web GPU matured on the web browsers as a standard and well implemented feature to be capable to run GPU routines through the JS. So there is an emerging point to integrate GPU feature as an underlying 3D rendering system to Web GPU, WebXR. So after many incubation and discussions, currently following schema is taken. So instead of making switchable interface to WebGL, new WebGPU bindings has been added. So it's not exchangeable or not switchable, but you need to start session with WebGL WebGPU. So you need to select which to use at the first moment. Of course, handling of 3D assets or rendering 3D contents using WebGL or WebGPU has a quite different mechanism, or you need to run different code to deal with these two. So of course you first need to select one to start a project. Also required interfaces or routines have been provided dedicated to WebGPU instead of reusing a interface to WebGL. Of course, output from this interface are the same as WebGL, so code after rendering might be the same, but WebGPU dedicated to handling are required. But in any case, WebGPU is now usable, integrated with WebXR, so now you can run GPU-based code to render 3D contents on the WebXR. Second, spatial content handling. This includes handling of physical points on the AR mode. So like WebXR anchors provide a feature from underlying XR hardware system to handle anchors tracked by unique ID, which has a 6DOF 3D position and 3D direction to be uniquely identified over the single session of WebXR. So you can handle 3D asset to be tied to anchors even if users moves or users change the direction or position. Like such kind of physical point related features are now under incubation to have a spatial content to the WebXR world. And this is a screenshot from OMBI, but this kind of physical integration is a quite a new emerging point to entire XR system, and I hope some sort of standardized data format or data sets could be generated in near future. So the last point is a model element proposal. I've briefly introduced, but this is a proposal to have a 3D asset as a first citizen on the web. So now we have image or video tag on the web, so you can show PNG or JPEG images or MPEG-4 video without any code on the web, just by using HTML element. But this model element proposed to run a 3D asset in the same position. So originally it was proposed to just have a 3D model rendering on the web as an image with clickable or with movable by the mouse, but now this is extended to have 3D features like a CSS integration or interaction using a JS or HTML attribute. In addition to that, there is some incubation discussion around autoplay or playback, and also environment maps to be provided by the 3D model, but many incubations are undergoing, so there's many discussions for new features. And in addition to that, some new 3D related features are under discussion or under proposed. One is a CSS spatial layout. This I will show some images in the next slide, but this is to introduce z-axis instead of z-index to CSS. So this makes CSS purely 3D. So the second one is a web spatial, means a spatial context over HTML element, like providing a 3D surface to HTML element. So I'd like to show, this is a quite emerging discussion starting from last year or this year, but this is a sketchable image for CSS spatial layout modules. So for z-index, all layers are stacked as a 2D surface, but this is a purely 3D spatial layout and to be rendered on the image. This module has just started incubation, so many attributes or many features may change. So if you have interest, please follow discussions. So I'd like to finish my presentation. The